Okay, so now we've done a calibration, we're going to measure how, or see how accurately we can measure physical distances using this calibration. I'm actually using a different grid here just to prove a point that evaluating can be done with a different grid. It doesn't have to be the same one. So as per the instructions, I'm running barred video calibration checker. I'm using the config file, and I've set the number of corners, and I've physically measured the size of the corners, and I'm using my previously saved calibration. So the console tells me that I'm loading. I can actually tell this is a bad calibration because this border shouldn't be round the edge. So firstly, if I press C, it again brings up this extra window so I can tell that it's detected the points correctly. And up here on the console you can see -39.19.253. So what is that? That is the origin of the chessboard is here in this top left corner. So the x-axis stretches along horizontally, the y-axis kind of vertically, and the z-axis perpendicular. So this position here is the position of the origin of the chessboard relative to the camera. So the Z direction in the camera space is looking towards and away from the camera. So this 253 millimeters, so what's that, 25 centimeters or so, which looks about right. If I go back here, if I press M repeatedly, what it's doing is it's grabbing the same image repeatedly, and even then you can actually see these picture on the left. You can sometimes even see the points moving, which just goes to show that image noise does affect the point detection, and consequently you see a mean position, but you also see a standard deviation of that top left corner. So we know that it's not perfectly accurate, but these here, the standard deviations, are fractions of a millimetre, so on average that's probably good enough. If I press C, it displays the current position. If I press T, it says it takes the last two measurements, or rather the measurement before and the current measurement, and tells you how far it has moved. So if I press T and I haven't moved it, you'd expect all the numbers to be near zero. But if I move my chessboard along by 5 millimeters, I'll be able to see it moving. So what I've done here is here's my web camera. It's pointing down at my laptop, and I've got this ruler lined up against, and it's butted up against the front of my laptop, and my phone is against the ruler, and I've also got these post-it notes up against the ruler. So these post-it notes are acting a bit like a carpenter's square, if that means anything to anyone. So if I move along my post-it notes, I can basically move by 5 millimeters in the X direction. So hopefully if I press T, you can see it's moved -4.6 millimeters, well, nearly 4.7 millimeters in the X direction, next to nothing in the Y, and next to nothing in the Z, which is what we'd expect. So what you could do is repeatedly measure blocks of or movements of 5 millimeters, collect the data, calculate the error. So in this case, instead of 5, it was -4.7 or so. You want to measure the distance across X, Y, and Z because it might not be perfectly aligned with the camera. So instead of moving 5 millimeters, we've moved 4 and a bit. And you do this repeatedly, and you can then essentially get a feel for how accurate this calibration is in real terms. I think that's enough for this demo. Thank you.